Alright, we're going to go ahead and get started with Lecture 1, Part 2 of our theories of acids and bases. We've just got done looking at Arrhenius acids and bases and the Bronsted-Lowry acid-base theory. The most important is the Bronsted-Lowry acid-base theory, and it's the one that we're going to test you most on. Just remember really quickly that a Bronsted acid is one in which a proton is donated, and the base is where the proton is accepted because it has a lone pair of electrons. Okay, we're going to speed through here to our end. We talked about conjugates, acid-base conjugates. Just remember that when we do one more example here, is such as, let's say OH minus, and we'll say that this is the base. And just when we make the conjugate acid of this, we just need to add one more proton, or just like so, and this is essentially H2O. And we got to basically remove the minus sign and have a neutral atom there in this case. Alright, let's try another one. Let's do NH4. NH4 plus. Okay, we're going to form the conjugate base by removing one proton to make NH3, like so. And so there's one proton difference and there's a charge difference because we've lost a proton. It becomes more on the negative or neutral side for ammonia. Alright? So there's the acid-base conjugated pairs, and I hope we're good with that. We're going to move into this word called amphoteric, and what that means. An amphoteric substance is one that can either act as an acid or a base. And in order to do that, they're going to have the following two features. To act as a Bronsted-Lowry acid base, they must be able to dissociate and release H plus ions. And to act as a Bronsted-Lowry acid, they must be able to accept a hydrogen ion, which means they must have a lone pair of electrons. Just very much like we've talked about before. Probably the most important example of an amphoteric substance is water. Water, H2O, has a lone pair of electrons, so it can be a proton acceptor and act as a base, or it has hydrogens, so it can donate hydrogens, and so in this case it would be an acid. So water is a common amphoteric substance. Just kind of look at that really quickly. Let's look what it draw this out. If water is going to act as an acid, it's going to donate let's say in one case it acts as an acid, in the other case it acts as a base. So in this case it's going to donate one of its protons to the base, and we're going to form a hydronium ion plus the hydroxide ion. Alright? So in this case our acid is going to become our base, and the base is going to become the acid. And we have our acid, which is the hydronium ion, and the base, which is the hydroxide ion. And we have our acid-base conjugated pairs here. And so water can act as an acid and base here. Very important for you to understand this reaction. Alright, there are many other examples of amphoteric substances that we will point out as we go on in class and do example problems. Alright, our last thing we're going to look at for Lecture 1 is what is a Lewis acid and base. This is our very final theory. Um, Lewis, this is the same guy who did Lewis structures. And he's going to expand our notion of what an acid and base is. We are no longer subject to an acid being one in which donates a proton and a base in one that accepts it. Instead, what Lewis is going to say is that an acid is anything that is an electron pair acceptor, and a base is anything that is an electron pair donor. Now, we've already talked about that a base has to have a lone pair of electrons. And so what Lewis is going to say is anything that has a lone pair of electrons and donates those pair of electrons to something is going to be a base. And anything that accepts a lone pair of electrons is going to be an acid. So let me give you an example of a Lewis acid and base idea. Alright, so if we had, let's say an H plus, and we had ammonia in H3. Okay, now in this case, this is just like a Bronsted-Lowry idea, but it's also like a Lewis acid and base idea, where the acid and the base is going to donate a pair of electrons, these pair of electrons, to the acid. And so the acid is going to accept it. So in a Lewis acid, it accepts the pair of electrons, and the base donates them, and we form an NH4 idea here. Draw the correct Lewis structure of this. 4 plus. Oops. Anyway, got the idea. NH4 plus. Now, another example would be like, let's do B. F3. Alright. And in H3 here. NH3 is going to donate a pair of electrons to the boron, and the boron is going to accept it. So the boron is going to be a Lewis acid, and the ammonia is a Lewis base, again because the base donates a lone pair of electrons to the acid, and the acid accepts them. So we form a molecule looks something like this, where we have those lone pair of electrons donated by the ammonia, like so. And again, those are the two donated electrons from the nitrogen to form this bond. Alright? So again, this is a couple of examples of a Lewis acid and bases. The biggest thing is just to remember that when we're looking at a Lewis acid, it accepts a pair of electrons, and a base is a pair of electron donor. And that's it. That's all there is to it. Alright? But what it does is just, again, allows us to expand our understanding of bases and acids, and it broadens it out. So we have a lot more substances that are acids and bases than just donating H pluses and accepting H pluses. Alright, so that is it for Lecture 1.